Welcome to Describing Statistical Distributions. We can display statistical data in different ways. This is a dot plot. This is a box plot. And we have the histogram. A histogram looks like a bar chart, and it is a type of bar graph, but it's different because the y-axis is frequencies, the frequencies of something occurring, which would be along the x-axis. When we're observing a distribution, we can describe it in terms of its shape. Might be symmetric, skewed, uniform, or bimodal. In terms of its spread, that would be, in general terms, the range of the distribution. We can look for outliers, data points that fall significantly outside of the norm, and in terms of its center. And in that regard, we're looking at the mean, the mode, and the median. Let's look at each one of these separately. So a skewed shape. If it's skewed to the right, you're going to see what looks like a tail going down to the right. See how you see like a tail? So you're looking for a tail to the right. If it's skewed to the left, you're going to look for that tail going down toward the left, where those values are getting smaller and smaller. Okay, other shapes that you might incur. When it is symmetric, both sides are about the same, and there's one larger in the center, so it's going towards the center, or away from, however you want to look at it. You have your bimodal, and the way you can tell bimodal is you've got like towers. You're going to see towers on the sides, and you have what's kind of looking like a cookie bite in the middle. And when it's uniform, this makes sense because, as you can see, the data values really aren't that different. They're pretty darn close to each other. I mean, 5, 4, 4, 5, 5, 4, 5, 5. Now let's look at spread. So we can look at this in terms of the range. This is the difference between the highest value and the lowest value in the data set. So in the dot plot, you see 8 as your greater value and your 1 as your lowest value. You subtract those and you get a range of 7. On the histogram, you can see that the lowest value is 10, but where the data points actually start is 25, and the highest value is 115. So we're going to say this range goes from 115 minus 25 is 90. Here's a box plot. This line right here represents the actual value of whatever it is. So which data points in this box plot look like they might be what we call outliers, points that are outside of the norm? Well, if the boxes represent data points, then most of your data points are falling in this area here. Clearly, these points here that look like little eyeballs because I've circled them are outside of that norm area. So we would consider those the outliers. Now let's look for outliers on different distributions. This one in the dot plot certainly appears to be an outlier. And outliers can be somewhat subjective. This might be an outlier. but since it really is right next to all the rest of the data, we should probably include it in all of our calculations. In our histogram, we see these values here as possible outliers, and same with this one here, over on the 8. But since there's really over 20 from a frequency standpoint of data points in this first box here, we might want to actually include those. And the last way we would describe our distribution is in terms of the center. And the three main measures of central tendency are the mean, the mode, and the median. So the median is the middle value that separates the lower half of the data from the higher half of the data. The easiest way to find the median from a dot plot is to cross off one data point at a time from each side, left, right, until you get to the middle. You can see we're doing that now. Now, since I can actually see that there's easily 7 on both sides before I'd get to something in the middle, I could cross off that whole 7 right off the bat, and then I could just keep going from there. Or I could see there's, probably at least 10, 7, 8, 9, 10. I could count over here and say 8, 9, 10, and I could do it in groups like that. Or I can do it one at a time like we see here. If I did it in groups, I could see that 13 and 13, and that would yield 1 in the middle. That 1 left in the middle, in order to make it be on both sides, we'd have to split it in half. So therefore, the median would be 13.5. Okay. Now the mode is the data value that occurs most often. This is fairly easy to see when you're looking at distributions that are represented in a graph form of some sort. In the first one, in the dot plot, the data value that occurs most often here is 6. And you can clearly see that because in the 6th column, that is the highest data point. And so that group obviously has the most. Over on the histogram, it's the same idea. You can look for where the bar goes the highest, and that is in this area right here. So it's in column 3. That's your highest data point. So since you have about 105 data points in here, well, that would tell you that 3, from a frequency standpoint, has been used, or what have you, 105 times, and that's the most. So the mode is the data value that occurs most often, and in this case it's 3. Now the mean is the arithmetic average of the data, and that means we have to actually calculate it. So we're going to add the value of each data point and divide the sum by the number of data points. So here we have our dot plot. We're going to take each dot and we're going to multiply it times its value. So it's 1 times 1, and then we have these 4 times 3. We have 5 here times 4. You can see how we're getting these. We have 5 times 5. We have 4 dots times 6. We have 5 dots times 7. And we have 1 dot times 8. Well, the total number of dots is 25, those data points. So we take the total after we do our multiplication, we add them all up, 125. We divide by the number of actual data points, and we find that our mean for this particular distribution is 5. To calculate the mean for this histogram, we're going to take each value that's along the x-axis, and we're going to multiply it times its corresponding frequency on the y-axis. Then we're going to add all the values together and divide the sum by the number of data points. Well, I see that this right here is approximately 25, so I have 1 times 25. I look up 3, and 3 looks to be somewhere around 105, so I say 105 times 3, and I do that for each one of these bars. Once I multiply it all out, I'm going to add all of that together, and I come up with a sum of 1570. I take 1570 and I divide by the total number of data points. If I were to add 20 plus 105 plus 90 plus 70 plus 80 plus what this appears to be approximately 8 or 5, I come up with 378. So my mean for this histogram, the calculation when I do the division, is 4.15. Okay, well that ends this very brief video on describing distributions. Enjoy the activity.